So now we'll start seeing how we can use the trig ratios and SOHCAHTOA to find missing sides in right triangles. So we'll spend a couple days on that, finding missing sides, and then we'll go into finding missing angles in right triangles. So you may only use Pythagorean theorem if you have 2 out of 3 sides in a right triangle. This will not always be the situation. Sometimes you have a side and an angle. So remember, we've got our 3 primary trig ratios, and SOHCAHTOA tells us what they are. And they use the sides opposite, adjacent, and hypotenuse. And that's always going to be our first step. We're going to label the sides of the triangle. Okay, Brooklyn? The side across from the right angle is always the hypotenuse. That never changes. To know which side is the opposite, you need to look and see what angle are you working with. You're either going to be given an angle that you're going to use, or you're going to be finding an angle. Whatever that angle is, in this case here, theta shows that that's the angle we're working with. The side across from that is the opposite. The third side is the adjacent. So that will always be our first step when we're using our trig ratios. Label the sides of the triangle.
We're asked to solve the right triangle shown below. Give the lengths to the nearest tenth. So when they say solve the right triangle, we can assume that they're saying, hey, figure out the lengths of all the sides, so whatever A is equal to, whatever B is equal to, and also what are all the angles of the right triangle. They've given 2 of them. We might have to figure out this third right over here. So there's multiple ways to tackle this, but we'll just try to tackle side XW first, try to figure out what A is, and I'll give you a hint. You can use a calculator, and using a calculator, you can use your trigonometric functions that we've looked at a good bit now. So I'll give you a few seconds to think about how to figure out what A is. Well, what do we know? We know this angle y right over here. We know the side adjacent to angle y. And length A, this is the side, that's the length of the side that is opposite. That is opposite to angle y. So what trigonometric ratio? What trigonometric ratio deals with the opposite and the adjacent? So if we're looking at angle y, relative to angle y, this is the opposite, and this right over here is the adjacent. Well, if we don't remember, we can go back to SOHCAHTOA. SOHCAHTOA. Sine deals with opposite and hypotenuse. Cosine deals with adjacent and hypotenuse. Tangent deals with opposite over adjacent. Opposite over adjacent. So we can say that the tangent of 65 degrees of that angle of 65 degrees is equal to the opposite, the length of the opposite side, which we know has length A, over the length of the adjacent side, which they gave us in the diagram, which has length 5. And you might say, well, how do I figure out A? Well, we can use our calculator to evaluate what the tangent of 65 degrees are, and then we can solve for A. And actually, if we just want to get the expression explicitly solving for A, we can just multiply both sides of this equation times 5. So let's do that. 5 times 5. These cancel out, and we are left with, if we flip the equal around, we're left with A is equal to 5 times the tangent of 65 degrees. So now we can get our calculator out and figure out what this is to the nearest tenth. Get my handy TI-85 out, and I have 5 times the tangent. No, I didn't need to press that second right over there, just the regular tangent of 65 degrees. And I get, if I round to the nearest tenth, like they asked me to, I get 10.7. So A is approximately equal to 10.7. I say approximately because I rounded it. I rounded it down. I didn't. This is not the exact number, but a is equal to 10.7. So we now know that this has length 10.7 approximately. There's several ways that we can try to tackle b, and I'll let you pick the way you want to, but then I'll just do it the way I would like to. So my next question to you is, what is the length of the side YW, or what is the value of b? Well, there's several ways to do it. This is the hypotenuse, so we could use trigonometric functions that deal with adjacent over hypotenuse or opposite over hypotenuse, or we could just use the Pythagorean theorem. We know two sides of a right triangle. We can come up with the third side. I will go with using trigonometric ratios, since that's what we've been working on a good bit. So this length b, that's the length of the hypotenuse. So this side wy is the hypotenuse. And so what trigonometric ratios, and we can decide what we want to use. We could use opposite in hypotenuse, we could use adjacent in hypotenuse. Since we know that xy is exactly 5 and we don't have to deal with this approximation, let's use that side. So what trigonometric ratios deal with adjacent and hypotenuse? Well, we see from SOHCAHTOA, cosine deals with adjacent over hypotenuse. So we could say that the cosine of 65 degrees is equal to the length of the adjacent side, which is 5, over the length of the hypotenuse, which has length b. And then we can try to solve for b. You multiply both sides times b, you're left with b times cosine of 65 degrees is equal to 5. And then to solve for b, you can divide both sides by cosine of 65 degrees. This is just a number here, so we're just dividing. We have to figure it out with our calculator, but this is just going to evaluate to some number. So we can divide both sides by that, by cosine of 65 degrees, cosine of 65 degrees, and we're left with b is equal to 5 over the cosine of 65 degrees. So let us now use our calculator to figure out the length of b. Length of b is 5 divided by cosine of 65 degrees. And I get, if I round to the nearest tenth, 11.8. So b is approximately equal to, rounded to the nearest tenth, 11.8. So b is equal to 11.8. And then we're almost done solving this right triangle. And you could have figured this out using the Pythagorean theorem as well, saying that 5 squared plus 10.7 squared should be equal to b squared, and hopefully you would get the exact same answer. And the last thing we have to figure out is the measure of angle w. Angle w right over here. So I'll give you a few seconds to think about what the measure of angle w is. Well, here we just have to remember that the sum of the angles of a triangle add up to 180 degrees. So angle W plus 65 degrees, that's this angle right up here, plus the right angle, this is a right triangle, they're going to add up to 180 degrees. So all we need to do is, well, we could simplify the left-hand side right over here. 65 plus 90 is 155. So angle W plus 155 degrees is equal to 180 degrees. And then we get angle W, if we subtract 155 from both sides, angle W is equal to 25 degrees. And we are done solving the right triangle shown below.
Okay, so that's how this works. So in that example, he solved the triangle, found all missing sides, all missing angles. We will see questions like that eventually, but for now, we're just going to find one missing side. That's what we're going to look at today. So the example says, find the missing side in each triangle below, round to the nearest tenth. So you can see in that first one, we want to find the value of x. What is that side? How long is it? We're given the bottom of the triangle, the base is 4.6 centimeters. We're given this angle here to be 30 degrees. And we can only use SOHCAHTOA or Pythagorean theorem if we have a right triangle. So That little box out in the corner there means that that is a 90-degree angle. We always start by labeling the sides of the triangle like we have been doing. The side across from the right angle is the hypotenuse. Because we're given this angle of 30 degrees, we're going to use that to find out what x is. The side across from that angle that we're going to use is the opposite. The third side is the adjacent side. This is always our first step. Now we have to determine which two sides we're going to use. And we're going to use the sides that we're given as well as the side we're looking for. We're trying to find x, which is the opposite. We're given the 4.6, which is the adjacent. So I'm going to circle those two sides. Those are the two sides that we are going to use here. So we have to look at SOHCAHTOA and see which ratio uses the opposite and the adjacent. And it's the tan ratio. That is the only one that uses opposite and adjacent. Sine uses opposite but not adjacent. Cosine uses adjacent but not opposite. The only ratio that uses opposite and adjacent is the tangent. And the TOA part tells us also the order that they are in. O is first, A is second. Opposite on top, adjacent on the bottom. So now we'll write our equation here. The tangent of the angle, which is 30 degrees, equals opposite on top over adjacent on the bottom. There's our equation. And this is important. If you can't get that part right, you're not going to get the right answer. Look and see which two sides you're going to use. That'll tell you what ratio you need to use. And again, SOHCAHTOA tells you what the two sides are and what order they must be in. The TOA part tells us that it's O first, A second, opposite on top, adjacent on the bottom. Now on the video, what he did next is he multiplied both sides by the denominator of 4.6. I'm basically going to do the same thing, but only I'm going to make the left side a fraction as well by putting it over 1. And whenever you have two ratios equal to each other, their cross products are equal. So I'm going to cross multiply. It'll be the same effect as multiplying both sides by the 4.6, which is on the bottom on the right, to get x by itself. It's going to be the same effect. So you multiply the pieces that are diagonally across from each other. 1 times x is x, and that must equal 4.6 times tan 30. Which we can now go to our calculator and figure out what that equals. All right, so again, you need to be in degree mode. My calculator's in radians right now. I switched it over yesterday for a different class, so I need to make sure I'm in degree mode. And now I can go 4.6 times tangent of 30. And to the nearest tenth, it would be 2.7 centimeters. So there's the value of x. Now we can look at the triangle and make sure that that answer is reasonable. The longest side, the hypotenuse, is always opposite the greatest angle, which is the right angle. The shortest side will be across from the smallest angle. This angle down here is 30 degrees. That is the smallest angle of the triangle. Remember, all three angles add up to 180. If I already have 90 degrees here, that means the other two angles must also add up to 90. 90 plus 90 is 180. So these two angles must add up to 90, which would make this angle up here 60 degrees. We're not asked to find that. However, I'm just doing this to make sure our answer is reasonable. The smallest side would be across from the smallest angle. 30 degrees is the smallest angle. The smallest side across from it has to be x. And the answer we got, 2.7, is definitely less than 4.6. Had we got an answer greater than 4.6, that would be a problem because the smallest side has to be across from the smallest angle. So you can always look at your answer and make sure that it is reasonable. as a check. All right, looking at the next one. We want to find the value of side y. There's our right angle. The side across from that's the hypotenuse. This will always be what we do first. Label the sides. Because we're given that angle of 22 degrees, the side across from that is the opposite, and the third side is the adjacent. Bless you. Because we're trying to find the measure of y, the side across from the angle is the opposite. And now we need to see which two sides we're going to use. We want to find y, which is the opposite. We're given 10.7, which is the hypotenuse. We're not given the adjacent. We're not asked to find it. We're not using it. We're using opposite and hypotenuse. And SOHCAHTOA tells us that the sine ratio uses opposite and hypotenuse. The sine of the angle of 22 degrees equals, and again, the SO part tells us it's O first, H second. Opposite on top, hypotenuse on the bottom. Must be in that order. So part tells us that O is before H. Opposite on top, hypotenuse on the bottom. So like I did in the last one, I'll make the left side a fraction as well, and then I'll cross multiply. When two ratios are equal, their cross products are equal as well. So 1 times y is y, and that will equal 10.7 times the sine of 22 degrees. So I always write it in that order. The sine of 22, or the sine or cosine or tangent of whatever angle, I always leave it last, and I'll show you why in a second. But we'll get our answer first by going 10.7 times the sine of 22, and that is approximately 4, which is reasonable. Okay, the 22 degrees will be the smallest angle in this triangle, so it has to be across from the shortest side. And 4 is less than the 10.7. If we got an answer greater than 10.7 here, that would be a problem, because the hypotenuse is always the longest side. Now, here's why I always leave the angle last when I write it down here and then do it in my calculator. If you go sine of 22 times 10.7, you're not going to get the right answer. Because what the calculator is actually doing there, it's multiplying the 22 by 10.7 first, which is going to give us a much larger number, Keen. And then you're taking the sine of a different angle. It will work like this, but you have to close the bracket after the 22 to make sure the calculator is just taking the sine of 22 and then multiplying that by 10.7. So it will work that way if you close the bracket after the 22 degrees. But to avoid that problem, I always leave the sine, cosine, tangent of the angle part till the end when I write that equation out. All right, question C. Start by labeling the sides of the triangle. The hypotenuse is the side across from the right angle. You're given this angle is 64 degrees. The side across from that is the opposite. Third side is the adjacent. In this case here, we're going to use the adjacent and the hypotenuse. We're trying to find z, which is the hypotenuse. We're given the 19.3, which is the adjacent. We're not asked to find the opposite, not going to use it. We need to use hypotenuse and adjacent. And SOHCAHTOA tells us that the cosine uses adjacent and hypotenuse. Those are the two sides we must use here, the adjacent and the hypotenuse. So we must use the cosine. The cosine of the angle, which is 64 degrees, equals, and again, the ca part tells it it's A first, H second. Adjacent on top over hypotenuse on the bottom. This one's a little bit different than the previous ones we did, because if we look back at the two ones we just did, the variable was on top of the fraction. Okay? If we look back, those two examples, the variable was on top. The variable was on top. In this case, the variable is on the bottom. It doesn't change what our next step is, though. We're going to make both sides a fraction. We're going to cross multiply, but I'm going to start with the pair, the pieces that I multiply together that have the variable in it, z. It'll be z times the cosine of 64 degrees equals 1 times 19.3. The two that we did on the previous page, when we cross multiplied, we had the variable by itself because the variable was on the top. In this case, though, the variable's on the bottom, so we don't have it by itself after cross multiplying. We have to do just one extra step. To get z by itself, we would divide both sides by the cosine of 64 degrees. We'll divide both sides by the cosine of 64. They cancel on the left, and we'll have z by itself. And now we go to our calculator and go 19.3 divided by the cosine of 64. So to the nearest tenth, that'll be 8.5. The digit in the 10th column is a 4, and the number to the right of that being a 6 means the 4 goes up to 8.5. Oh, thank you. And I would have got that maybe if I would have checked, because 8.5 should be the biggest side. It's the hypotenuse. It is smaller than 19.3. So I would have realized that when I did my check. But thank you. Yes, I need to divide 19.3 by cosine of 64. 44, approximately. Which makes sense because it needs to be the longest side. That's bigger than 19.3. Okay? So looking at this next one, we start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. We're going to use a 28-degree angle because we're given that. The side across from that is the opposite. Third side is the adjacent. So in this case here, we're going to use the opposite and the adjacent. We're trying to find x, which is the adjacent. We're given the 42, which is the opposite. Those will be the two sides that we would use. And SOHCAHTOA tells us that the tangent uses the opposite and the adjacent. When we write our equation here, the tangent of the angle, which is 28 degrees, equals. And again, the TOA part tells us it's O first, A second. Opposite on top, adjacent on the bottom. Make both sides a fraction by putting the left side over 1 and cross multiply. And when you do that, you'll have x times the tangent of 28 degrees equals 1 times 42. And then to get x by itself, we would divide both sides by the tangent of 28 degrees. So those will cancel on the left, and we'll have x by itself. So again, in this case here, we have that one extra step because the x, the variable, is on the bottom. After cross multiplying, we didn't have it by itself. We had to do one extra step to get that by itself. So 42 divided by the tan of 28. If I round that, that would be 79. Which again, the 28 degrees would be the smallest angle. It needs to be across from the shortest side. So my adjacent side has to be greater than 42, and it is. Okay? Let's do this next one together. We want to find the value of x, which in this case is the hypotenuse. That's the side across from the right angle. We're given the angle is 70 degrees, so we're going to use that. The side across from that is the opposite. The third side is the adjacent side. We want to find x, which is the hypotenuse. We're given 54.6, which is the opposite. The ratio that uses opposite and hypotenuse is the sine ratio. The sine of 70 degrees equals, and the so part tells us that it's opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. Make both sides a fraction, and then cross multiply. So it'll be x times the sine of 70 degrees equals 1 times 54.6. And again, because the x was on the bottom when we first wrote our equation, after cross multiplying, we don't have it by itself. We have to do one extra step to get that. We'll divide both sides by the sine of 70 degrees. So 54.6 divided by sine of 70. 58.1 to the nearest tenth. And we can put the units there because the opposite is in feet. This would be as well. And remember, the hypotenuse has to be the greatest side. And this answer, 58.1, is longer than the 54.6 that we were given. So that answer is reasonable. Right, try B on your own, and then we'll check it. You need to go blow your nose? Okay, go. Yeah. Well, the sides that you're using tells you what formula to use. You're using opposite and hypotenuse. That's why we start by labeling the triangle and circling the sides that we're using. That tells you it has to be sine. The so part tells us that only sine uses opposite and hypotenuse. If you have adjacent and hypotenuse circle, then that means it must be cosine, because only cosine uses adjacent and hypotenuse. And if you have the opposite and the adjacent circle, that means it has to be tangent, because only tangent uses opposite and adjacent. Yep. All right. Start by labeling the sides. Side across the right angle is always the hypotenuse. We're given that angle of 33 degrees. The side across from that is the opposite. The third side is the adjacent. We're given the angle 33 degrees, so we're going to use that angle. So the side across from that is the opposite. In this case, we're going to use the opposite and the adjacent. We're not given the hypotenuse, not asked to find it. Y is the opposite side, 10.1 is the adjacent. Those are the two that we're going to use. And SOHCAHTOA tells us that the tan ratio uses opposite and adjacent. The tangent of the angle, which is 33 degrees, equals the opposite, which is y, over the adjacent, which is 10.1. Must be in that order. The TOA part tells us that it's O before A, opposite on top, adjacent on the bottom. Make both sides a fraction so we can cross multiply. And in this case, because the variable y is on top, when we cross multiply, we have it by itself. 1 times y will equal 10.1 times the tan of 33 degrees. So now we go to our calculator. 10.1 times the tangent of 33. 6.6 would be the answer, rounded to the nearest tenth. And that would be in centimeters because the adjacent side is in centimeters. That side is also across from the smallest angle, so it has to be the shortest side. Y must be less than 10.1, and it is 6.6. Okay? So that's how we use trig ratios to find missing sides of triangles. Example 2 then on the next page. Andrew is kayaking at Cape St. Mary's Ecological Reserve. He sights the northern gannet rookery on Bird Rock. And you can see that the angle from where his kayak is up to the top of that rock is 50 degrees. We also see that his kayak is 84 meters away from the base of the rock. We want to know how high Bird Rock is above sea level. So we want to find h, or x, which is the height of this rock. So we're going to use trig ratios. We start by labeling the sides of the triangle. Right? This angle down here in the bottom left will be the one that's 90 degrees, obviously. The side across from that is the opposite. Excuse me, the hypotenuse, I apologize. The side across from the angle that we're using, which is 50-degree angle, is the opposite. The third side is the adjacent. That's always our first step. Label the sides. The hypotenuse never changes. That's always across from the right angle. But the opposite and the adjacent will change. It just depends on which angle you're working with or using. In this case, we want to find x, which is the opposite. We're given the 84, which is the adjacent. We are not given the hypotenuse, not asked to find it. We're using opposite and adjacent, which is the tangent ratio. So the tangent of the angle, which is 50 degrees, equals, and TOA tells us that it's O before A, opposite on top, adjacent on the bottom. Make both sides a fraction. Yes, sir. Yep. It's the same result as if you cross multiply. It'll be the same thing. Yep. So 1 times x is x, equaling 84 times tan of 50 degrees. And I showed you why I always put the sine, cosine, tangent of the angle last in our calculator. You don't have to, but you need to make sure that you close the bracket on the 50 degree if you put that part first. But 84 times the tan of 50 is 100.1 to the nearest meter. It would be 100 meters high. To the nearest meter. So this is one of the practical applications of trigonometry. Okay, that's quite high, 100 meters. That's over 300 feet. That's like 30 stories high, basically. So pretty tough to run a tape measure that length. But using trigonometry, having a couple of calculations, which Surveyors would have the instrument to measure this angle, as well as knowing how far away they are from the base. You can use trigonometry in order to find the height of that cliff. If you drive around at all out of town, even in town, lots of towers have guy wires. So they are just wires that support the tower so that in case a big wind comes, it won't fall over. So they're attached at some point on the tower, and then they're usually fastened into the ground, usually by some kind of a concrete base that's sunk into the ground. And usually they'll have more than one guy wire. Sometimes they'll have 4 guy wires, one coming from each direction, just so you never know which way the wind is coming from. But in this case here, we've got that picture that shows the guy wire supporting a radio transmission tower. The wire reaches 55 feet up the tower and forms an angle of 65 degrees with the ground. We want to know how long the guy wire is to the nearest half foot. So we want to know what L, the length of the guy wire, is. So we know what we're looking for. Now we label the sides of the triangle. Side across from the right angle is the hypotenuse. That's what we're trying to find here. We're going to use the angle of 65 degrees because we're given that. The side across from that is the opposite. Third side is the adjacent. The adjacent side would represent how far from the base of the tower the guy wire is attached to the ground. That's what the adjacent side would represent, but we're not trying to find that. We're trying to find L, the length of the guy wire, which is the hypotenuse. And we're given the height of the tower, I guess how high up the tower the guy wire is attached to, which is the opposite side. We're not given the adjacent, not asked to find it. We need to use the opposite and the hypotenuse, which is the sine ratio, the sine of 65 degrees. It's always the sine cosecant of the angle that you're working with. And the so part tells us that it's O before H. Opposite on top, hypotenuse on the bottom. The hypotenuse, the length of the guy wire, is what we're trying to find. Make both sides a fraction, cross multiply. So when you do that, it'll be L times the sine of 65 degrees equals 1 times 55. Because L, the variable, was on the bottom when we set our equation up, after cross multiplying, we don't have it by itself. We need to do the one extra step to get that, which is divide both sides by sine of 65 degrees. So they'll cancel on the left. We now have L, the length of the guy wire, by itself. And we can find out what that is by going 55 divided by sine of 65 degrees. Should be the longest side of the triangle because it's the hypotenuse, and L is greater than the height of 55. It does say round to the nearest half foot, which would be 60.5 feet approximately. Right, that number is closer to 60.5 than it is to 70. When we round to the nearest half a foot, it'll either be a 0.5 or a whole. And that number is closer to 60.5 than it is to, I'm sorry, I said 70. It would have been 61. To the nearest half foot, it says. So it's either going to be a 0.5 or a whole. And that number of 60.685 is closer to 60.5 than it is to 61. So that's why it's 60.5. Okay? All right, we'll stop there. I'll hand out the assignment. This assignment, I will post the solutions to Google Classroom. We'll do some more of this on Monday, and then I will be collecting that assignment for marks on Monday.